My name is Rafael, and I want to tell you about my senior project. For my senior project, I plan to design a system to sketch lines and curves onto a sheet of letter-sized paper. The geometry will be held within DXF files, which are universal drawing files, easily exported and shared between solid modeling software. I got the idea for this project from the XY table set up in SET 449. An XY table is a system allowing uniaxial motion on perpendicular axes independently and simultaneously. The XY table was set up to trace lines between points fed through LabVIEW. I saw the endless facets of the XY table as a project and decided to design a system building on what I saw. Plus, automation always intrigued me, and this is a chance to get some hands-on experience. To accomplish the task of translating lines and curves held within DXF files, I will develop a program using LabVIEW to determine a series of points to trace between. Sketch geometry is held within a DXF as an identifier followed by key information. This is an example of an entry within a DXF file. This is for a circle. We can see the type of geometry, and some other points we can see are the X value and Y value and the diameter, since it's a circle. And we also have this space 0 at the end. This signifies the end of the element, and it moves on to the next element. The program I will develop will allow the user to specify how precise curves will be generated. Some options I have explored are as follows. First, I looked at specifying a max central angle for the sectors of the circle, that central angle being the theta shown in this diagram. This will work well when the geometry is composed of circles and arcs. I also looked at specifying max curve length between points. This would work well for more free-form curves. A combination of the two will be used to accompany small circles and arcs, as well as parabolic and sinusoidal curves. You can see as when you're specifying a curve length and you get really small circles, you can end up with inscribed polygons with far fewer sides, leading to more error. The system will be able to precisely and accurately recreate the geometry by navigating between points within 5,000 inches of the actual position. This will be achieved by using encoders to verify the pen's location at all times. So this is the system that I'm proposing. This is my concept drawing. So I have rails, linear rails, in the X and Y direction, and I'm using lead screws to displace this common block along the curves. And it's meant to move a pen, and this pen is loaded with a spring, and that spring is adjustable to change the weight of the line. Each servo motor will have an 8-bit encoder providing 1.4 degrees per bit sensitivity. These will use in tandem with 10 threads per inch lead screws, displacing 0.1 inches linearly per revolution. Theoretically, the accuracy achievable is plus or minus 0.4 of a thousandth of an inch. Most of the error for the system is expected to come from flexibility of the writing instrument, though. There will also be that adjustment for changing the line weights. So here are the block diagrams I have for the angular encoder and the load cell, or strain gauge if I choose to use that instead. So the measurand for the encoder is the linear displacement, even though we're directly measuring the angular displacement. And the signal conditioning to take place is to change the count from the encoder to an appropriate linear displacement through the use of an equation or formula node. and that value will be read out on the front panel, and it will also be used for subsequent calculations. And the measurand for the load cell is the force from the spring, and the conditioning to occur will be calibration using software and an equation as well. And this value is meant to be read out on the front panel. Now, the goals of this project, the overall goal is to just be able to insert a flash drive, select your file, and just run it and let it create the curves. Some deliverables of the project are a complete drawing package, including all necessary drawings, part numbers, and assembly details to successfully assemble the machine. Also, complete assembly in Inventor and SolidWorks, followed by a complete LabVIEW program tested and verified on the XY table in SET 449. And these are the references that I used for the images. I want to thank you for your time and attention. I hope you see the value in this project as being a great opportunity to expand my toolbox with experience and hopefully proficiency of automation and measurement techniques. The measurement techniques were recently learned in instrumentation. There were some mechanical properties used that were learned in mechanics of materials, and some of the other geometry and mathematical relations were discovered throughout the mathematical coursework here at Alfred State. Thank you.